Hello everyone, this is Dr. MiteshGala. Welcome to Rough Book, a learning companion.
Hi, we're getting into logarithms exercise 8A. Logarithm is a topic basically not very difficult, but yeah, very logical. So you need to pay attention to the start and then it will become very simple. Logarithms is usually used in real world in order to make bigger calculations very simple. So when you have very huge calculations, for example, the distance between sun and earth, the distance between galaxies or something like that, which calculations are very huge, okay, wherein putting the numbers becomes very difficult, logarithm helps you greatly to do all of that. So if you go on Google and type how is logarithm used to calculate distance, you will get ample of videos in order to understand that. Now what in logarithm we need to understand from this exercise point of view. Let's come back. So logarithm is basically one step further of indices. For example, if you have 5 cube 125, 5 cube we already know 5 into 5 into 5, it is 125. This is basically nothing else but exponential form. We call this as exponential form. If you are converting this exponential form into logarithmic form, how are you going to present it then? So how do I remember? Log 5 cube equals to 125. I remember it as a cycle. 5 cube equals to 125. That's how you can remember. How do you read this? So you read this by saying log 125 to the base 5 is 3. That's how you read it. Log 125 to the base 5 equals to 3. But how do you write it? I generally don't remember to write log 125 to the base 5 as 3. How I write is log 5 equals to 3 or log 5 3 equals to 125. So 5 cube is 125. That's how I remember. You can remember it the way you want, but that's the easiest method. So will you remember this, how to convert exponential form into logarithmic form? This is very important for your first exercise. If you do not know how to do this conversion, you will mess up. Once again, let's take one more example. Let's take 6 square 36. So logarithmic form will be log, how do I write? Log 6 square equals to 36. This 6 is at the bottom, a little below G. 36 is on the same line. So let's say if this is your line, right? You will write it like this. Let's take this as the line. One more example. 7 cube 343. So logarithmic form, and let's say if this is your ruled page and this is your line. So I'll write it as log 7 cube equals to 343. So this is your proper numbers and this goes down. Will you remember this? How to convert exponential into logarithmic and logarithmic into exponential. So 7 cube equals to 343. That's how you can remember. So we understood both the parts. You also need to remember few laws of indices which we've already done in indices, but I'm repeating them. So one of the law most important, a raised to m equals to 1 upon a raised to minus m. You remember this? Second one, a raised to 0. Anything raised to 0 becomes 1. And third one, a into b raised to m becomes a raised to m into b raised to m. So these are the laws of indices which you need to remember so that we can apply the same with logarithm. Logarithm is basically building on indices. So will you remember this? Great. This is very important. A raised to m equals to 1 upon a raised to minus m. Last thing, if you have log a plus log b, then the law of logarithm says you can pull out log common and this plus will become multiplication. Likewise, log a minus log b. If you pull out log common in this case, then this minus will become division. But it doesn't go reverse. If you have, let's say, log a into log b and you pull out log common and you say a plus b, this is wrong. This is not acceptable. Likewise, for division also not acceptable. Remember that, I repeat it. Log a divided by log b doesn't become this. This is wrong. Only this can happen. Reverse doesn't happen. That's the rule of logarithm. So what you can do is, only when you see a plus sign, you can pull log common and say multiplication. When you see a minus sign, you can pull log common and say division. But it can't go in the other way. So take a screenshot of this, put it on your softboard, because this is going to be your flow chart for the first exercise. So if you know this, you can easily tackle your first exercise. So please take a screenshot of this, put it on the softboard, and then go ahead. So let's begin with the first one. They say convert. They are not asking you to solve. They're telling you just convert this into logarithmic form. So logarithmic form, what will happen? So how do I write? Come on, pause the video, write it. Log 3 equals to minus 2, 1 by 9. So basically 3 raised to minus 2 is 1 by 9. Likewise log form. Come on, pause, go ahead everybody. So it's going to be log 81, 3 by 4 equals to 27. So basically log 27 to the base 81 equals to 3 by 4. How do you read this? Can you read this one for me? Log 1 by 9 to the base 3 equals to minus 2. Are you getting it? Convert this logarithmic form into exponential form. So come on, exponential form everybody. It's simple. 8 raised to minus 1 equals to 0.125. The cycle is this way. Remember, that's the current. It starts from here, goes here, and then comes back. Boomerang. Are you getting it? Come on, one more. Pause the video, try it. Exponential form. A raised to x equals to capital A. Simple. Are you getting it? It's very simple. Trust me, logarithm, you will enjoy this chapter. By the end of this exercise, you will say, oh, it was so simple. I never knew it. Come on, let's try the next one. This is given to you. Your target is to find the value of x. So convert into logarithmic form, and that will give you some clue. And 100% you will get it on your own. Try it. Convert to exponential form first. So 10 raised to minus 2 equals to x. So basically x is 1 upon 10 raised to 2. This is your indices, which becomes 1 upon 100, which can be written as 0.01. So therefore your x becomes 0.01. Simple. What is difficult in this? Nothing. You just have to understand. That's it. So we first converted to exponential form. After that, the law of indices. So minus goes down, becomes plus. Raised to 2 means 100, and 2 zeros means decimals. That's it. Can you try the second one for me? Write this in this format first. This is 4 part 1. Come on, pause the video. Log 100 to the base 10 equals to x you should write, because you are trying to find the answer of this. So let's write it equals to x. Now is this exactly similar to this? So convert this into exponential form and then try it. 100% you will get it. Come on, try it everyone. And if you get it, shout out loudly that I got it. Come on, try it. So 10 raised to x, 100. Did everyone wrote this exponential form? So 10 raised to x. What can I write for 100? 10 raised to 2. Bases equal, index equal. Basically now you are getting back to indices only. So therefore x is equal to 2. Did you get it? Shout out. Don't shout so loud, the neighbors will come at your place. As if something's wrong. Come on, come back. 4 part 3. Convert, write this in logarithmic form. Then convert to exponential form. Supply an x to it and solve it. Pause the video. Come on. So log 0.001 to the base 10. Write it as equal to x. Convert to exponential form. 10 raised to x, 0.001. So 10 raised to x, 1 by 1000. So next, 10 raised to x, 1 by 10 raised to 3. Let's get this on top. So I will get 10 raised to x, 10 raised to minus 3. This is your law of indices, and therefore x becomes minus 3. Since bases are equal, index is equal. You may not mention that reason unless your teacher insists in school. Otherwise, this is fine. Are you getting it? Yeah? Let's take the next one. Come on, everyone racing with me. How many of you are racing with me? Pause the video. Let's try it. So log 0.125 to the base 2, calling it as equal to x. So 2 raised to x, 0.125. Stuck? Remove the decimals. So 2 raised to x, 0.25 by 1000. Again stuck? Cancel. Divide by 25. So 25 4 times, sorry, 25 5 times and 25 40 times. 5 ones are 8s are. So 2 raised to x 1 by 8. So 2 raised to x 1 by 2 raised to 3. 2 raised to x 2 raised to minus 3. So what will I get the value of x? Simple. We are going to use the same things again and again. Nothing new now. So come on, hit it with the next one. 4 part 8. Who's getting it for me? Come on, everyone. So log 1 by 81 to the base 27x. Convert into exponential form. So 27 raised to x 1 by 81. Convert. See, both are 3 raised to something. So convert it in the form of 3. So I will call this 27 as 3 raised to 3 into x. And 81 will become 3 raised to 4. Law of indices, get this on top. So I will get 3 raised to 3x, 3 raised to minus 4. Bases are same, so the index is same. So x becomes minus 4 by 3 or minus 1 by 3. Writing it in the mixed fraction. Are you getting it now, everyone? So minus 1 by 3. Could you manage to get it? Brilliant. Come on, convert this exponential form directly and get your answer. 6 part 1. Pause, get it, and then only come back. It's very simple. If you don't get this, what to say? So 3 raised to 0 equals to x converted to exponential form. Anything raised to 0 is 1. So 1 is equal to x. That's it. You don't trust me? It's correct. And that's it. Don't expect such type of sums in the exam. You're going to get slightly tougher than this. They're just building your base right now. Okay. So don't be too happy if you get it. Alright, next one. 9 raised to x 243. Converted to exponential form. Convert both with the base 3. And then say bases equal, index equal. Try it. So this will become 3 square. This will become 3 raised to 5. See, 3 3s are 9, 9 3s are 27, 27 3s are 81, and 81 3s are 243. So 5 times 3 is what you get. Bases are same, index is same. If you can't get this, go on to your rough side, take prime factors and then come back. So x is 5 by 2, or you can say 2.5 or 2, 1 by 2. So mixed fraction also is fine, decimal also is fine. Are we clear with this? Brilliant. The next one. 4 raised to x minus 4, 32. 4 raised to x minus 4 is 32. So 4 will become 2 square x minus 4 and 32 will become 2 raised to 5. How many got this on their own? Then why did you come back? Come on, finish the sum and then come back. So 2 raised to 2x minus 8, 2 raised to 5. Bases are same, so index is also same. So what will I get then? So 2x, 8 goes on the other side, becomes 13. So 13 by 2. Write it in decimals or mixed fraction, whatever you want. I am writing it in decimals. So 6.5. Are you finding this very simple? Isn't it going with a very simple pace and very smooth? Because you guys are smart. I am not joking this time. Come on, try next one. 6 part 6. Pause, convert to exponential form and go ahead. So 7 square, 2x square minus 1. So 49. Pushing this one on the other side. So 50, 2x square. Pushing 2 down. So 50 by 2 gives me x square. So I will get x square as 25. So x will become what? Plus or minus 5. You can write only 5? No. Please write plus or minus 5. Both can be accepted. So you need to mention plus or minus 5. Unless your teacher tells in school not to mention it. Okay? Come on, next one. 7 part 1. They say evaluate. Means find the value. If you don't have your RHS, create by writing equals to x. Convert to exponential. 100% you will get it because we are doing the same thing. Nothing new. Come on, try it. So 10 raised to x 0.01. 10 raised to x 1 by 100. 10 raised to x 10 raised to 2. Get this on top. Law of indices. So 10 raised to minus 2. So therefore x becomes minus 2. Base is same. Index also is same. Are you enjoying it? Great. I am really happy for you. Come on, go ahead. 7 part 4. Again a very simple sum. Write it as equal to x and come on, hit it. So I will get 5 raised to x as 125. 2 more steps and you're sorted. So 5 raised to x, 5 cube. So x is equal to 3. Did you manage? So don't be excited. Such sums are not expected in the exam. They're just building your base. Come on, next one. Again is equal to x. Get this one. This is slightly tricky. If you get this, I will be impressed. So 0.5 raised to x, 16. Now what to do? Bases are different. So convert this 0.5 as 5 upon 10. And this will be 2 raised to 4. When I cancel this, some connection. So 1 by 2 raised to x equals to 2 raised to 4. This is 2 raised to 1. When this goes up, it becomes minus 1 into x and 2 raised to 4. So bases are same. Index is also same. So x basically becomes minus 4. It was a trick. They said 0.5. So you have to convert 5 by 10, cancel, and then you get 2, bring it up, and then you can say bases equal, index equal. So there was a trick in this one. How many managed to get? Genius. Good job. Ninth one. Now sums are slightly tricky. They are building now a step further. So they have given you these two parts. They want you to write this in terms of x, and then they want you to write this in terms of y. So this we'll look at it later. First let's look at this and convert it into exponential form. So convert into exponential form and then come back. So this will become 2 raised to m equals to x and 5 raised to n equals to y. So now we know at least that 2 raised to m is x and 5 raised to n is y. Let's pick the first one. 2 raised to m minus 3. This is your law of indices now. If it is minus in indices, what happens? Divide. So this will be 2 raised to m divided by 2 raised to 3. See, you split this. Basically law of indices. If it is division, you say m minus 1. But when you go reverse, then you supply the division sign. Now what is 2 raised to m? Already known to you as x divided by 2 cube, which is 8. So 2 raised to m minus 3 is x by 8. So you converted the entire expression in terms of x without m at all. Can you try the second one now without my help? 5 raised to 3n plus 2. So law of indices first, and then at some stage you will be able to write 5 raised to n as y. So first apply law of indices. Come on. So 5 raised to 3n plus becomes multiply and 5 raised to 2. One more step, 5 raised to n cube. See, when you multiply this again, law of indices, 3 into n becomes 3n and 5 square is 25. Now I can say 5 raised to n is y. So I will get y cube into 25. So basically I will say 25 y cube. That's the answer for 5 raised to 3n plus 2. Basically they are building you for bigger sums where this will become a part of that. That's why you need to know these basics. So they're taking baby steps for you. Please see to it you don't copy all this. You should get it. Are you managing this part? Brilliant. 10th. If you manage 9th, now 10th should be simple for you. So first convert this into exponential form, and then you need to write 72 raised to a in forms of x and y. So that we'll see. First convert this. So 2 raised to a becomes x and 3 raised to a becomes y. So you got x and y in terms of a. Now take 72 raised to a. Take the factors of 72. So let's take it. 72, 236, 218, 29, 33 and 31. So what do I get? I get 2 raised to 3 and 3 raised to 2 raised to this a. So I have converted this 72 in terms of 2 and 3. Why? Because I wanted it to convert it into x and y. Now supply this a to both. So 3a and 2a. This is again law of indices. Now how do I write this? Pay attention. 2 raised to a the whole cube, 3 raised to a the whole square. So when I multiply, it remains the same. Then why did I write it this way? Because I knew that 2 raised to a is x. So I can now substitute this as x cube into 3 raised to a is y. So y square. So now I have got 72 raised to a in terms of x and y. Intelligent, isn't it? Not you, the sum I'm talking about. Alright, that's good. Let's go to the next one. Sum number 11. Law of indices I taught you. When there is plus, what happens to log? You can pull out log common, and what happens then? Try it. If you remember, try it. I will be impressed if you get it on your own. If you don't get it, I will help you. So I'm pulling out log common. I will get x minus 1 and x plus 1 to be multiplied together. So when you pull log common, plus becomes multiplication. On this side, 2 log 1 to the base 2. Log on both sides can get cancelled, and this will become x square minus 1, and this stays as 1 because this log 2 log is got cancelled. Send 1 on the other side, so I will get x square as 2. So x will become root 2, but plus or minus, write both. Yeah, so your x becomes plus or minus root 2. Are you getting it? Okay, before we go to the last sum, one last thing I want to explain it to you. If I say I'm doing it on the same page, so this one page becomes your master key. If I say log something is 2. Now if nothing is the base, it is assumed that the base is 10, right? So if I say 10, then what will be my answer over here? It's going to be 10 raised to 2. 10 raised to 2 means 10 square. 10 square will be 100. Likewise, if I say log 3, so here it is always assumed as 10. What will be my answer here? So 10 cube becomes 1000. If I say 4, again this is assumed as 10. So here I will get 10 raised to 4, which is 10,000. And what if I say 1? Base is still 10, so 10 raised to 1 becomes 10. Last thing, what if I say log something 0? So this is 10. 10 raised to 0 becomes 1. So what I am trying to teach you is, if you see 1, you should put 1 0. If you see 2, you should put 2 zeros. 3, 3 zeros. 0, no 0, only 1 then. So these are the values which help you to convert. So if you see 2, you should write log 100. If you see 3, you should write log 1000. If you see 0, you should write log 1. Why did I teach you this? This is your sum number 12. So you see 2. If you want to cancel log from both sides, you have to create a log over here. So you've seen 2. So for 2, what will you write now? Think. I just taught you. So log x square minus 21. And I will write over here log 100. Why 100? Because I just taught you, if this is 2, you will write 2 zeros. This base 10 is always assumed. You don't need to write that. So if it is 2, I can write it as log 100. Are you getting it? Why did I write this? So that log and log can get cancelled. And I will get x square as 2100. I just started the sum, but I forgot to tell you that you have to prove this, that x is equal to plus or minus 11. So now it's very simple. Come on, finish it. So x square 121. So x is root of 121. So x becomes plus or minus 11. That's what you have to prove. So always put plus or minus sign. Otherwise you will mess up the entire sum. Are you getting it? Great job. For your homework, I want you to do 1 part 1, 2 part 4, 4 part 4, 4 part 7, 6 part 5, 7 part 2 and 7 part 3. I hope you enjoyed this exercise and most of you all managed to get all the sums. Until the next video when we do the next exercise, please see to it you do your homework honestly so you get the next exercise very easily.
Hope you had a lovely mathematics experience with the Rough Book, our learning companion.